Right, so here's the close. That last video stopped just a little bit short. Things that I want to mention from that one are, let me get back here, clear out a few things. This last equation, the y minus k, when it's squared, the y portion is squared, it faces left and right. H and k are still the x and y coordinates of the vertex. It's just that that y portion is squared, so it faces left and right. P still is the distance from the vertex to the focal point, but in the picture, you want to look at it. This is, when it faces left and right, the p is a distance to the left and right. If it's a negative p, the parabola faces the left. If it's a positive p, it faces to the right. So p is the distance from vertex to focus. And so just keep an eye on those little details. I'm going to do a couple examples now, and I think that'll be enough. Let's just save the circles and ellipses so you guys can, for tomorrow when I get back. But what I gave you today is enough to tackle. And if you want to work ahead, I'll load more videos on our Google Classroom page, so you should be good to go. Now this example that I have here, it's a x squared, so you always want to take note of what part is squared. So you're going, oh, this is an up-down one, so it's definitely facing up-down. Okay. And then what I'll do next is the coordinate of the vertex is embedded in there. It's the hk, and the fact that this is a +2 means it's actually a -2, 1 is the coordinate of the vertex. And I'm going to leave it to you guys to kind of work out. Remember, it's the formula is x minus h and y minus k, so it's the opposite of what you see. So -2, 1 is going to be your vertex. Which way it opens, the direction it opens, is to look at this number here, which is 4p. That means p inside there is 2, and you have to make that deduction. Like the 8 is the whole quantity 8 stands, which is going to be 4p. So the direction it opens, because the x is squared and it's positive, this one faces up in particular. The axis of symmetry is just the x coordinate, so it's going to be a vertical line, x equals -2. Since it faces up and down, it would fold along the x equals -2 line. And the coordinate of the focus is, if I go over here and graph it, this is where I get to the point where I start plotting all this stuff, because everything else falls into place. So -2, 1 is the points of the vertex. We found out that p is 2, and that's actually something from the beginning. It would have been good to say, all right, here's 8. The right away I would have said, ooh, that means p has to be 2, because that quantity 8 is 4 times whatever p is. And that means since it's facing up, we're going to go up 2 to the focus. And do you remember the other dimensions on there? Do you remember that p is, not only is it the distance up to the focus, it's the distance down to the directrix is the same amount. So I'm going to use this kind of p value. And then the directrix is this horizontal line that gets drawn underneath there. Okay. Now, the other part of that p direction is that it goes 2 times the distance p to the left and right. It gives you portions of that parabola. So here's p over, and then p again to the left, p over, and then p again to the right. But if you go back up to the pictures up above, that dimension p describes a whole lot of the shape of how this parabola goes. I'm going to draw this. I don't know, let's pick blue. That would be a good color. But if you're wondering how to draw it, you know the parabola faces up, so we got this part going. But remember, 2p to the right and left gets you parts of that parabola as well, and that's what we need. We actually need those 2 other points. 2p, p is a distance, remember, of 2 units, to the left and to the right. We know this faces up because p is positive, okay? And it all ends up looking something like this. This is our sketch that we can get just from knowing p and the vertex. We've shaped, that's the sketch of our parabola. Now the other questions are pretty nice to act. It says coordinate of the focus. I draw the picture and then go, oh, well, there's my focus right here. Remember, that's the point. So focus right there, and the coordinates of that just go, it's -2, 3. I can see it from my graph, so -2, 3, and then we can finish out the rest of this. But I think the graph is where you want to put your focus. Definitely work from the graph itself. Okay, so it says the equation for the directrix. Now again, you look at this graph that we drew. It's a horizontal line at -1, so y equals -1 would be the equation of that. Okay, so in coordination, I start with the equation, I get my vertex, figure out what direction it opens, get my p, then I go over and start graphing, And then from there I can get the coordinate of my focus and the equation of my directrix really nice from the graph. I highly recommend the graph. I'm always looking for that sketch of that graph. Cool. Down below is one more example of one that faces the other way. We'll do that, and then the tricky ones down below, I think you can work it out. It works. You're going to work from the graph, work your way backward. The vertex, if you want to look at it, remember here's h, that's the x coordinate, here's the k. Can you see it's 4, -1? Because the x minus the h, 4, -1. So that x and whatever number subtracted is going to be your x coordinate, and y and whatever number subtracted from that is going to be your y coordinate. Which way it opens, if you look at, this is -6, that's 4 times whatever p is. That one's a little harder. So this is what I do. You actually set up a little equation. 4p, I know that's the number in front of there, is equal to -6. And if I just do a little division here, I can figure out, oh, that means p has to be -6/4, which is also known as -3/2. So that's 1.5. Okay. And you can use -1.5 if you like, because that's an easier thing to plot. Done. Okay, it's a lot of information. But you notice it's also negative. So if this is y squared, remember this is a left-right facing parabola. And the fact that it's a -p means it faces the left. So this opens to the left. The axis of symmetry is going to be, because it's facing left and right, it's going to be the line y equals -1. If I can only draw a y here, so y equals -1. I'm using my finger instead of my stylus. It's kind of tricky. So y equals -1. So let me go over and draw what we have so far. 4, -1 opens to the left. So you go 4, -1. Got it. It opens to the left. My p is -1.5. So I got that point for my focus. That's a lot of information. If I do that -1.5 to the other side, you get your directrix. But if I label these things right now, thank you. Oh, thanks, Ethan. You brought the stylus for me while I mentioned it. And then so you got the focus, and then we got this directrix. And so, oh, that's so much easier. There we go. And then the parabola. If 1.5 is the p, you guys are going to see all my emails this morning. But then 1.5 is the p direction. It's 1.5 to the directrix. Remember, the vertex is given in the equation, the -h and -k coordinates. Okay, so those are all the pieces. Then 1.5 units, if you did 2 times whatever p is, which is 1.5, so there's 1.5, and then there's 1.5 more. That's going to be the edge of the parabola. 2p down to 1.5, and 1.5, which you know is 3 total. Those are the edges of our parabola. So we have all the information that we need. This is enough to draw a rough sketch of it. Vertex, p is -1.5, so you go to the left for the focus, to the right for the directrix, and then 2p down and 2p up for the edges of the parabola, and then we can sketch it within that. So got it like that, and like that. Okay, there's your sketch, and then the equations of things and the points that you want you can put in there. So the coordinates of my focus looks like it's going to be 2.5, -1. Okay, so that's my focus. And then the directrix has an equation x equals, because it's vertical this time, it looks like 1, 2, 3, 4, 5.5. 5.5. Okay, so those are the pieces that you needed, and you're set to go. Now the ones down here, it's working backwards. I recommend this. Would you find what you have to do in the bottom ones? Your job is to find HK, whatever that is, and P, because you know where they fit in that from the graph, from sketching, from plotting these points. Okay. So what you have is evidence, like here's some clues, basically, of what's in the graph. You're going to draw those things and say, okay, where's my parabola fit in there? Can I deduce the h, k, and p? Now, you also have to know which equation you're dealing with. Are you doing the left-right equation, or you can do the up and down equation? Is the x part squared or the y part squared? And then your job ultimately is to write the equation, but totally get the graph, sketch it, and work from there. Enjoy.